I am Allie Adam.
And I am Isabel Ion. We are reporting live from Channel 5 Action News.
We're always ready with breaking news about science.
We are always trying our best to inform you about the latest discoveries about science.
Today we are going to teach you all about chemical reactions.
You will get to see news reporters from all over the world with breaking news about chemical reactions.
Now over to Anne from Antarctica. Hi, I'm Anne, and I'm reporting live from Antarctica. It is very cold here. I wish we had a fire. Maybe I can use a combustion reaction to make one. Combustion. This reaction occurs when a substance reacts with oxygen to produce energy. An example is if you have coal and then you have a lighter and you heat it with fire, the coal, which contains carbon, reacts with oxygen in the air and it creates heat. So when you burn the coal, it reacts with oxygen and it makes heat so you can stay warm. Now over to Maria from Mexico.
Me llamo Maria. Soy de Mexico. Hace calor. But I have a synthesis reaction which can make water. It is 2H2 plus O2 yields 2H2O. The synthesis reaction, now I have water. Refreshing.
Sarah the scientist in her lab.
Sarah the scientist. According to my new research, I have found a double displacement reaction. The reaction of barium nitrate with potassium sulfate is an example of double displacement. So it's BaNO3 plus K2SO4 yields BaSO4 plus 2KNO3.
Hi, I'm Deborah the dentist, and I'm going to show you how single displacement, a chemical reaction, can help make fluoride, which is what we use to put on people's teeth. The formula is 2NaCl plus F2 yields 2NaF plus Cl2, and that's a compound plus an element yields a different compound plus a different element, and they switch around so it's single displacement.
Reporting live from Channel 5 Action News.
Hello, I'm Allie Adam.
And I'm Isabel Ion.
Today we're going to give you some helpful vocabulary to help you understand chemical reactions. Chemical equation is a way to describe a chemical reaction using chemical formulas and other symbols.
Coefficients are numbers that represent the number of units of each substance taking part in a reaction.
Oxidation number is used to describe the loss or gain of electrons.
Reduction is to describe the gain of electrons.
Exergonic reaction is a chemical reaction that releases energy.
Exothermic reaction is when the energy given off is primarily in the form of thermal energy.
Endergonic reaction is when a chemical reaction requires more energy to break bonds than is released.
A catalyst is a substance that speeds up a chemical reaction without permanently changing itself.
Inhibitors are substances used to slow down a chemical reaction. Our last word, diatomic molecule, is when two elements are joined together and there's just like one, but it's two elements combined. So like H2 or O2 would be a diatomic molecule. This is an exergonic reaction. The reactants produce a product that releases energy. This is the endergonic reaction. This means that more energy is given off when the reaction takes place than the product gives off. So the reactants, as you can see on the chart, don't give off that much energy. But then when they start to react, they give off more energy. And the products, they don't give off that much energy either. So the highest amount of energy is being given off when the reaction is taking place and the bonds are breaking. So this is an endothermic reaction. Energy is absorbed into a substance with less energy, and then it produces a substance with more energy than before. The exothermic reaction is the opposite of the endothermic reaction. The reactants have more stored energy, and the products have less stored energy, and energy is given off. This is how we balance chemical equations. The equation is C4H6O3 plus H2O yields C2H4O2. So the first thing we're going to do is write down all the elements that we have. We have carbon, so we're going to write that. And then we have hydrogen, write that. And then oxygen, we're going to write that. And now we say how many atoms of each we have on each side. So carbon, there's 4, so we're going to write a 4. Hydrogen, there's 6, but then there's 2 more right here. So 6 plus 2 is 8. And then oxygen, there's 3 here, and there's no subscript right here, so that means there's just 1. So 3 plus 1 is 4. And on this side, there's 2, 4, and 2. So right here, since 2 times 2 is 4, 4 times 2 is 8, and 2 times 2 is 4, we can just add a 2 right here. And this, if you multiply 2 times 2, that's going to change this to 4. And 2 times 4 is 8. And 2 times 2 is 4. So now all of these are equal, and we have a balanced equation.